Today's lesson is on logarithms. So they kind of look funny and they sound funny, but they are related to the exponential function. So we'll be converting between exponential function and logarithmic function. All right, so first we're going to talk about inverses and how the exponential function and the logarithmic function are inverses of each other. So just like adding and subtracting, multiplying and dividing, something squared and something square rooted, they undo each other. They're inverses. So similar here. Starting out, I am just going to graph y equals 2 to the power of x. Let's just make an xy table. So if I plug in -1, that's 1/2. If I plug in 0, it's 1, 1, 2, 2, 4, 3, 8. And I'll plot those quick. -1 up 1/2, 0, 1, 1, 2, 2, 4, 3, 8. Okay. So we've had practice graphing the exponential function. When we are talking about inverse functions, we switch x and y. So it's like x equals 2 to the power of y. And then in my xy table, that switching those would also mean switching the x and y in the xy table. So I'm going to rewrite this table, but flip-flopping my x and my y. So I'll have 1/2 -1, 1, 0, 2, 1, 4, 2, and 8, 3. All right, so let's see what happens when I graph those. So write 1/2 down 1. Write 1, 0. Write 2 up 1. Write 4 up 2. Write 8 up 3. So what it does, it's kind of like this flip. And what it technically is, it's like this reflection over this diagonal line. And let's see, exponential function, remember how they have that horizontal asymptote? Well, the logarithmic function has a vertical asymptote. So another way to write this function right here is the logarithmic function, which is y equals log of base 2 x. Y equals log base 2 of x is how the proper way to write the inverse of this exponential function. So we'll get more into graphing at a later lesson. Now we're just going to look at how to convert back and forth between these two functions. All right, so we're looking in general terms, logarithms with base b. So I want you to first think about an exponent with base b, and then we're comparing that to a logarithm with base b. So where we put our bases. So b to the power of y equals x. So that's the inverse of the exponential function where we switch x and y. But the proper way to write it is log base b of x equals y. So the base of the exponent is the base of the logarithm. The exponent is what it's equal to. And then the x is next to the logarithm. And then this is just a side note. If we ever write a logarithm with no base, if there is no base, technically that is base 10, and we call that a common logarithm. So whenever there is no base, it means base 10. All right, starting out real easy, it's just converting from the two forms. So starting with a logarithm, so let's say I have log base 2 of 8 equals 3. we're converting it to the exponential form. So we have everything in here. It's base 2, so the base, and then to the power of 3 equals 8. And then just check, does that make sense? Is 2 to the third power 8? Yes, it is. Let's try one more. So the logarithm base 4 of 1 over 256 equals -4. So we're just rewriting it in the exponent form. So the base of the logarithm is the base of the power. 4 to the power of -4 equals 1 over 256. Check to make sure what you wrote down actually makes sense. It does, because negative exponents mean fractions. So 1 over 256. All right, and now just going the other direction. So we're starting with exponential and switching to logarithm. So if I have 15 to the power of 3, and that equals 3,375. So if I write that as a logarithm, that will be logarithm, and then let's see, base 15, logarithm base 15 of 3,375 equals the exponent. All right, so next one, 4 to the power of 1/2 equals 2. Remember, power of 1/2 is the same thing as square root, so that makes sense. All right, but to write it as a logarithm, so log base 4 of 2 equals the exponent. Log base 4, 2 equals 1/2. 4 to the power of 1/2 is 2. All right, last two examples. This time, I'm just giving you, so log base 3 of 81. So here's a logarithm I want you to evaluate. It's not equal to anything. So you could think of it as like equal to y. And then we have to solve for y. So let's rewrite it as an exponent form that has base 3. 3 to what power equals 81? Well, 3 to the 4th power equals 81, so y equals 4. So log base 3 of 81 equals 4. All right, one more. Log base 16 of 4 equals y. Let's find y. So base 16 to the power of what equals 4? How can I raise something to a power but the number decrease? Well, let's see. I know the square root of 16 is 4, and square root, oh, that's right, 16 to the power of 1/2 is 4, so y equals 1/2. All right, so there is kind of your introduction lesson on logarithms. Good luck.